I start, I'd like to point out that I've got quite a few slides, and we're already running behind. I'd ask you to defer questions to the end if possible. And okay, network interaction. What we mean by interaction is really how you would integrate your network into the rest of the operating system. The goal here is to have seamless access by the user. Unlike some of the other talks that you've heard earlier in this conference, this one is primarily in the user mode, so it's not file system strictly in a strict sense, not file system talk, and it's not about writing redirectors. If you want to find out more about that, Joe Lin's talk immediately after this one, or rather after lunch, will be the one that will give you all that good information. Okay, here we have some of the goals that we've set out to achieve when we talk about network interaction. The first thing is access to multiple networks at the same time. The idea being you can go to one machine and you can access a Novell server and an NT server or a Banyan server and all at the same time. The second goal is to have a network independent interface for applications. This is at a Win32 level. You want someone to be able to write an application using Win32 and not have to call network-specific APIs, so that you can basically use this for all networks. We also provide common user interface for users, and this is basically for browsing and connecting to networks, so for common dialogues and that kind of things. And a user doesn't have to go ahead and learn about different types of UI, how to do different things differently for different networks. And finally, we want to achieve the effect of a single login for the user, so that when you do Control-Alt-Delete and you log into the system and supply your username and password, you just do that once, and you don't have to do that again for every single network that's on the system. Okay, we've got multiple mechanisms achieving the goals that we mentioned in the previous slide. I will just briefly run through them now, and we'll talk about them in much more detail in the slides to come. First of all, we have the multiple provider router, also known as MPR. This is essentially the layer that gives you the Win32 APIs and the common dialog APIs for networks. And we have the multiple UNC provider, or MUP. This gives you a universal naming convention for accessing files and directories across the network. And we have the print provider interface that gives you remote access remote printers of different networks from your desktop. The authenticating provider interface, the one that gives you the single login capability. There is the name registration and resolution APIs, also known as R&R. This is new to Daytona. It's not in Windows NT 3.1, and this is primarily geared towards addressing client-server applications talking over sockets. And the goal here is to be able to do registration and resolution of services. And finally, we've got things like file manager extensions and other user interfaces that let you integrate your network much more seamlessly into the operating system. All right, here we have a simplified picture of what really goes on. And in this picture, we only show three of the components of the ones up, or three of the mechanisms of the ones of in the previous slide. If you look in the middle row, you will see MUP, MPR, and the spooler. I'm not sure you can read it from over there, but it's on the left it says MUP, the middle one says MPR, and the on the right says spooler. And above the three components, you will see interfaces that are exposed, and these are the common interfaces that can be used by applications. So at the very top, you will see an arbitrary application, which I'll just label as app, the Windows NT shell, the file manager, which is also referred to as WinFile because that's the name of the executable, and printman, which is the print manager. So we've got a common file system interface through MUP, a common Win32 interface for the WNet APIs through MPR, common printing interface through the spool APIs. And if you look below those three components, that's where the different networks lie. And each of the components essentially acts as a router that directs each operation to the appropriate network. The example I've shown here, we have two networks, and that they are like two that are shipping directly with Windows NT Daytona, and that is the client services for network and the Windows NT LAN-MAN redirector. Okay, we're going to go into the multiple provider first. This is a list of all the capabilities that you achieve via the MPR interface. First of all, we support file and print browsing, so you can browse network resources, and here we're talking about browsing for servers or domains in the LAN-MAN world, as well as things or servers and shared printers. And the second thing is file redirect, and here we're talking about what you would do, for example, if you're mapping a drive to a network resource. So you map to server volume or LAN-MAN terminology when you do something like that. And the print redirection cable. I've said this to be basic print redirection because the print provider interface that we'll talk about a little bit more later on, more powerful interface, at least just read LPT1 to a network print example. But this is really like second best. It's also got the ability to give supplemental credentials so that when you connect to a server, you can specify a username or a password, and this is really useful. Your password actually need to supply a different account. And I mentioned common user interface we tried to do. So common network dialogues. Think of this like file open dialogues that you see when you go to an application, try to open. And MPR also supports remember the connection sections that are established every time you log on. So you log off, you come back to the to your workstation next, and your connections are exactly as they were. And this is also kept in the registry, and it's kept in the producer part of the registries. If you walk from one machine to another, things should just show. Okay, and as I've said about MPR, all of these are done in a networking manner. Okay, to achieve those things, what MPR does is it exposes a bunch of Win32 APIs, which are the common networking APIs. And here I've just listed some of the more common ones. The first one is add connection, the WNet add connection API. That lets you make a connection or create the redirection or mapping that we talked about. And note that when you actually do this, you do not necessarily have to make a redirection. You can actually just specify a network resource and just make a connection to it. Typically, you might want to do this if you're not interested in doing file IO operation, but you just want to connect to a server for remote administration or something where you need a different set of credentials, for example. So this is a good way of doing that. And then the cancel connection is pretty obvious. It just deletes the connection you've made. The connection dialog is the one that provides the common user interface for network browsing and connection. The enumeration APIs is basically a set of three APIs. You have open enum, close enum, and the enum resource, which is actually the actual enumeration itself. The model here is very much a find first, find next model, as you would expect in the Win32 APIs. And it gives you a hierarchical view of the network. So think of the network as a virtual top of this hierarchy. And when you enumerate the top of this hierarchy, what you see is a list of networks or providers. And then each network itself can expose its own hierarchy. So in the NT case, what you will see when you enumerate the Microsoft network is you will see domains. And when you open up a domain and try to browse underneath it, you will see servers. And underneath a server, you will see shares. And in the, say, a network environment of at least a 3x environment, at the very top, you might start off by seeing servers, and then you go down to see volumes and directories underneath that, and so on and so forth. Okay. Now, note that these APIs are actually used by the file manager and the net.exe and the open file dialogs. Net.exe is the net use command, the command that you would type from the DOS prompt to make connections and that kind of things. So what this basically means is that if you write a network and you implement a network provider, all these utilities and tools will just work for your network automatically. All right, since we're trying to specify network resource in a network independent manner, we basically have to devise a way of doing this. And the key structure that we have here is a net resource structure. This structure is used when you try to connect to a network, and also is also used when you're enumerating resources, and this is in fact what is turned from an enumeration. The structure contains information like the path, the remote name of that particular resource, the type of the resource, whether it's a file or a printer. Also, it's like whether it's connectable, so that you can actually attach to it, whether it's a container, and if it is a container, you can go and use this for enumeration to browse further down. Okay. So the remote name is actually the one that's actually used for routing. This is the one that actually identifies the particular network resource. This is the only part of that particular resource which is also network dependent. So I've got two examples over there. You see the server share, which is a LAN type of name, and you see a server volume directory, which is a Novell kind of name. Within the net resource structure, there's also a local name, and this is optional, and this corresponds to the redirected device that you have for this particular network resource. And finally, when you specify a network resource, you can actually name a provider. So if you're trying to add connection, and you know that you specifically want to go to a particular network, you actually name it. Typically, you would expect people not to do this because you want it to work for all networks, but if you really do know that you want to go somewhere, you can go ahead and do that. All right, another thing we talked about was supplemental credentials. You can specify supplemental credentials when you do the add connection call, and this is basically just a way of specifying a username and a password. Username actually is network dependent in the sense that you can specify anything you want, and in the NT case, it could very well be domain / username, and for another network, it could be something else. And this is really useful when you have to connect to a server and you don't necessarily have the right account. The account that you're logged on, that's not necessarily the right account, or you have the same account with a different password. If you specify null, which means you're specifying a set of credentials, and what happens is that you make a connection using the security context of the current process. Now, this will typically be the security context of the logged on user, because most of the processes that you see on the desktop will belong to the user in that sense. The common exception that people need to watch out for is basically what happens when a service tries to access a network, because services in general, unless you specifically configure it not to, will run the local system in the local system context. In that specific case, you can do one of two things. You can either configure your service run under a specific account, which can be done in the control panel applet and can also be done programmatically if you need to do it, or you can go ahead and, when your service actually tries to hit in the network, do an add connection with a specific set of credentials using these APIs. All right, I'm going to quickly go into what it takes to write a provider from PR. It's actually fairly straightforward. You start by writing redirector, of course. That's something that Bill will talk about later. And as soon as you already have a redirector, you need to register your provider with MPR by writing to some part of the registry. It's somewhere in the registry tree, and it's all in the specs if you need to look it up. And then you create a DLL with the appropriate entry points. For all the APIs that we looked at before, which are the WinNet APIs, you basically start with WNET. The network provider has an NP equivalent, which is the provider equivalent. MPR just calls through the provider ones. And finally, you set registry order you set a provider order in the registry. This is all. Well, we'll talk about this in the next slide. How does NPR work? NPR is implemented as a DLL. It's when an app starts up and an app calls one of the WinNet functions, NPR gets loaded implicitly, and then NPR will go ahead and read the registry to find out what providers are registered. And only when an app actually makes a call to a WNet function will NPR load the various providers. So we do kind of a lazy loading over here. We don't really load it until it's called. And at that point, what NPR does is that it will pass that particular call to the various providers, because typically, say, for example, you're doing an ad connection, you give it a network resource structure, and the network resource structure contains a remote path, and that path, the providers will just probably just reject it, saying, okay, I don't recognize this path, it's not mine, go away, and the next guy picks it up, and eventually someone will pick it up, or maybe no one picks it up, in which case the call fails. So what NPR does is just pass this particular network resource to each of the registered providers in turn. And of course, the first successful call stops the routing. Note that NPR is stateless, so we do not remember information on what connections have been made or not. The reason behind this is that someone could actually go to a provider underneath us and make a change, like delete a connection or stop the particular redirector, and we may not necessarily know about that. So NPR itself maintains no state; it's purely just a DLL. And if you query anything, we go right back to the providers and say, hey, what's X code connected to, and so on and so forth. And the exception to this is the what we've talked about in the remembered connections. Once they get restored every time, that is something that we do keep and store in the registry. Okay. The next mechanism is the multiple UNC provider, or affectionately known as MUP. UNC, I'm sure most of you are familiar with, is a universal naming convention. And if you look at the example over there, that's essentially what the syntax of a UNC name is. You have double backslash and then a server name, backslash, share, and so on and so forth. This gives you programmatic access to remote files and directories in a very convenient manner, also from the command.exe, which is the DOS prompt. By programmatic access, what we mean, of course, is that a call to the Win32 Open File API with UNC name will just succeed. And what MUP does for you, it allows multiple redirectors to participate in this universal naming convention. As a note, I'd like to point out that we actually do encourage people to use UNC as much as possible. So if you're writing a network redirector, you really should try to have a UNC provider as far as possible. The reason that we like people to use UNC names is that you don't necessarily tie up a drive letter, and especially if you're a service or background process, you really want to leave the drive letter to the user and not making connections underneath what the user is doing. And writing a UNC provider. First of all, we need to implement a remote file system or redirector. And after that, it's not really too much on top of that. You need to register with MUP by calling the FSRTL register UNC provider function. What this does, it registers your redirector name with MUP, so he knows about you. And you also pass it information like whether you support the starts and that kind of stuff. And after that, you need to respond to the IOCTL, which is the IOCTL reader query path. And this is what MUP uses to query whether you actually own this resource or not. And this is just a device IO control. And finally, when you shut down your director, you need to deregister from MUP. Whoop. Sure.
The register UNC provider, is that get written in the register permanent from there on?
No. Every time your driver loads up, you should register with MUP. It is not.
What's the question?
Okay, so sorry. The question is the register UNC provider call, whether that's persistent and whether it's remembered or written in the register somewhere. And the answer is you should call it every time your file system driver starts up. Okay, how does MUP work? MUP is a special driver that's loaded during system boot time, and it keeps a list of providers that have registered with it. Okay, so when a file request comes in, MUP will basically submit a query path request to all registered providers. This is the IOCTL we just saw in the previous slide. And then it will wait for responses from all the redirectors or providers, and it will route the original request to the one that accepts that particular query path. If no one accepted the operation or the file, then the operation fails. Right. Now, when a provider accepts a path, it also indicates how much of that path it owns. And I'll show you more about what this means in the coming slides. Well, I'll give you an example rather in the coming slides. MUP actually takes this path. I think it's a typo there. It says path length. You might want to just cut out the length and just say remembers this particular path that the provider accepted. And it stores in its prefix table. This is basically a caching mechanism so that if someone else comes in with the exact same, something down the same path, it doesn't need to go and hit all the providers and say, hey, who owns this more? And if more than one provider accepts a particular path, there's a registry order that is kind of like what NPR has, and it will just go to the first one in the preference list. Okay. Let's work for an example. So supposing a use types dir double backslash chuck back public, where chuck's a server and public's a share. Now, MUP registers itself as the owner of the UNC namespace, so this is translated to back device, back MUP, back chuck, back public, and MUP gets it. MUP will go ahead and pass this to all the registered providers. And in this case, since it's a landman server, the landman provider accepts it and claims that portion of the path, which is chuck back public. MUP goes ahead and says, okay, I'm going to change this path to back device, back landman redirector. It knows that's landman redirector because that's the name that was given by the landman redirector to MUP when it registered earlier on. So it changes to that name, and then it completes this ERP with a status repass. This ERP gets repassed by going through the file system again, and it ends up with the landman provider's time. So continuing on this example, chuck C public has been cached in MUP's prefix table. So now if you access a file directly under this particular point, it would just go directly to land redirector, and MUP does not bother rerouting. Couple of other special cases worth mentioning. If there are no UNC providers registered with the system, MUP will just fail all UNC paths, so it doesn't bother hitting any redirectors then. And if there's exactly one UNC provider, then we'll just give all UNC requests to that guy and not bother keeping prefix stable either. A few more notes on MUP. Hash prefixes are eventually timed out. I believe the timeout period right now is like 15 minutes. The time a prefix is reused, or reference, should we say, the cache gets, the timestamp gets updated. So as long as you keep using it, you're okay. But if you don't use it, it gets timed out. And MUP is only involved in path-based operations. Once you've opened a handle and you're doing a handle-based operation, it's just not involved after that. It just goes straight to the redirect. And finally, mail slots. Mail slots, you can do broadcasts over mail slots, so it handles slightly differently than a normal file system. The main difference here being the open will go to all the providers, and subsequent I/O requests will go to every single provider that returns status success for the open. So that's how you achieve a broadcast. What are mail slots for? That's the question, by the way. We can talk about mail spots, I think offline, because it's very simple inter-process communication mechanism and you can do broadcasts over that.
Another question regarding where does the binding happen between the disk, the X colon and the UNC name? Is that done by the provider?
Okay. The question is where does the binding between X colon and a UNC name happen? The context of MOB that we just talked about, there is no X colon. You're basically doing a straight UNC access. Where you do have an X colon and you've redirected X colon to a particular network resource, that is basically, in Windows NT, a symbolic link. So X colon now is mapped to, in the landman case, back device, back landman, redirector, back whatever. And so it goes directly to redirector after that. So it's basically just a symbolic link under DOS devices. Okay?
How is it set up?
Okay, how is that? The question is, how is that symbolic link then set up? It is set up by your network provider. When I do a net use X colon to something, that goes through MPR, the WinNet add connection, to create a connection that gets routed to the providers underneath. The landman provider, through its workstation, will actually set up that symbolic link. There are actually ways of doing this in Win32 APIs. Okay, print providers. Sorry, does you have a question?
Yeah, just so I get the sequence straight, when MUB parses it in the first place and he comes back with a status reparse, the IO manager will then, presumably this is going to be a create request. It's going to reappear at the director and inform an creator.
Correct.
And then once the creator has responded to status success, the handle will be given back, and then subsequent ERPs just magically reappear at the redirector file.
Okay. Print providers. Print providers is actually another MPR-like interface, and it allows you to have integrated access to remote network printers. It gives you common from the print manager, including browsing for printers on remote networks. And it's not just that, because from the print manager, if you've written a print provider, you can go ahead and say, connected to a printer, I can go and pause the printer or continue it, or actually reorder the jobs or delete the job and that kind of things. So actually, it's more than just connection and printing. It also lets you do remote administration of diverse printers. And of course, it gives you programmatic access via the Win32 APIs, because that's where it's implemented. And the print manager just calls the Win32 APIs. One other note on printing, and that is the printing system, like MPR, also remembers printers. So if you connect to a printer and you log back on the same machine, actually it will just remember it and will get re-established every time. Okay. Creating a print provider, well, again, it's very much like MPR. There are no surprises here. You supply a DLL of a known entry point. The main one being initialized provider or something like that, which lets you return a table of entry points or a table of functions to the spooler, which it then uses. And you add your provider to registry. You can do this by, this is actually a little bit more convenient than MPR, because there is an API to do it, and that is add print provider. And there is an ordering associated with print providers, so that we route in a particular order, deterministic order. The print provider API is actually very rich. There are over 37 functions that can be implemented, but write a print provider, you do not need to implement all of them. Key APIs that you need to worry about are things like obviously printing, job management, and pausing a queue, that kind of things. And as an example, the client service for NetWare that ships to toner probably implements less than half of the functions over here. If you don't implement all the functions, you probably are not a full provider. And what we usually mean by not being a full print provider is that you not support the get printer drivers call. If you support that, what you're basically saying is that your server has all the printer drivers loaded, and actually physically on the server, so that the client machine, when it's talking to a server, does not need to actually have the drivers over there. Now, in the case where this is not the case, kind of obvious statement, but where this is not the case, what happens is that if you go to the print manager and you're connecting to a printer, you see this little pop-up which says, well, this server does not have the appropriate drivers, please enter the path, and that's when you enter it. But if you are a full print provider where your server has all the various drivers actually reside on the server, you don't even see that pop-up just work.
This question? In what environment do the print devices run? This sounds like another high performance. Is this user mode?
Okay, the question is what environment does the print provider run in? Is it user mode only? The answer is yes. The print provider is basically is all DLL based and belongs to the spooler. Oops. Okay, the question is where are the print provider's functions documented, because he's only seen the network ones, WinNet ones so far. There is actually a spec for it. I don't necessarily know if they're in SDK right now, but if you talk to Dave Beaver, he will definitely point you to them. And Dave, if you're listening, we should probably make sure this is in the DDK or SDK somewhere.
Passwords that are reestablished when you connect to a remote print device?
Okay, so the question is, are passwords remembered when you connect to a remote printing device?
A network printer that has a password on it.
Right. Right. We actually do not cache passwords in NT, so if you log off and log back on, you will need to resupply a password. But what happens is that when you log on initially and we're trying to reestablish connections, you have a chance to, the various providers and network router MPR itself will actually detect that if it's trying to reestablish a connection, that it failed with bad password, it will actually come to you right there and then say, okay, enter the password for this particular thing. So we remember the user context in the sense of which user it was, but we do not store passwords for security reasons. Okay? Right. Spool implementation. This is just an overview of how these things work. Again, very much like NPR, name and map, name-based APIs are routed in this specified order. Routing stops at the first accepting provider. Handle-based calls go directly to the appropriate provider. And in the printing case, there's always a local print provider, which is the local one that serves local printers. Single logon. Okay. So the idea here is you only want to log on once and supply your username and password once. The way this works is that logon, when it logs on, will pass that information, or rather will notify all providers of your particular user logging in. And what this allows you to do is that the providers get a chance here at logon to actually request for additional information if need. For example, if your network for the same user has a different password, you could actually come up and say, look, please enter the password for this guy, or please enter some additional information because we don't have it right now that we need right now. And the same thing happens for changing a password. When you do Control-Alt-Delete to change a password, we'll change the NT's password first, and then after that we'll change the passwords for the other providers that are registered as authenticating providers.
Do you treat username as case insensitive? It seems like username always gets translated to uppercase.
That very much depends on the network. I mean, you can very well treat it as case sensitive or case insensitive. Is it always passive in application? Just to prevent Oh, okay. So the question is, when you get to the login screen, the username is always uppercase. I can't remember where we do the uppercasing, but there might be something just done in the UIs. Right.
you have a case signature.
Okay, that's very feedback. We should probably make sure that if we are uppercasing the username every time, when we remember it, we should not do that in future. We'll take a note of that. Thanks. The authenticator provider is actually an extension of the MPR interface. What you do here is basically say that you have a flag in the registry which says that I belong to the authenticating provider class, and you support two functions, login notify and the change password notifies, which are callouts that you will get from WinLogin and the change password UI. Oh, and typically you can actually just use the same DLL as you would for the network provider. There's no reason to have a separate DLL. You just have some extra endpoints in it. Okay, one important point that we need to make sure we're clear on is that this is login notification. This is not authentication in a strict sense. What happens when you Control-Alt-Delete and you log on is that WinLogon logs onto Windows NT. After that, it notifies the other providers that user X has logged on with password foobar. The providers don't have a chance to go and tell NT, hey, I want him. Don't let him log on. This is just purely notification. You get told that something's happened. You don't really tell T that I don't want to accept this user. Now, a provider can go ahead and cache this information for the user in context, so that if it needs to make a connection later on, it knows about the security context and the password, and it just work. Now, since log actually gives you password in plain text, you have to be very careful here. I'm sure in an earlier talk by either Robert or Jim Kelly would have told you about all the things you shouldn't do, and obviously some of the ones are like don't store it on disk, and if you do have it in paging memory, make sure you at least encode it.
It's user mode. That's user mode. That DLL can be replaced by anybody and get all password.
Yes, yes. The question is, this is user mode, and this DLL can basically be a security hole. Well, yes and no. If you what you have to do to make this work is that you have to go ahead and modify the system registry to actually say that this is authenticating DLL. Now what will happen is that you can protect that particular part of the registry of ACLs, and if you're a really secure system, your system32 directory and all those things should be properly protected as well. This is no bigger a security hole than if someone just basically changed the netuse command and just replaced the executable with another one that basically caches a password somewhere, right? Okay, we've already mentioned that a provider bring up additional dialogues to query for information and alter and password and that kind of things. And the final point I want to make here is that the same thing happens during service logon. As we've said, services typically run this local system, but if a service is configured to log as a different user, the same notification happens, so that when the service accesses the network later on, the right security content will be used. And if it is a service log, you actually will know via a flag that's passed to you during this notification time that this is not an interactive log and this is not a good time to pop up a dialog. Okay, change password. Well, there isn't a whole lot new to talk about here. It's exactly the same as the thing we talked about before. But the providers get a chance to change your own passwords, and you can bring up your own dialogues as you need. The final point that's been snuck into this particular slide by someone else and actually belongs to the previous slide, so something we've already covered, and that is do not deny logon, you just notify. Okay, name registration and resolution, also known as R&R. This is new to Daytona. That's Windows NT 3.5, and it's very much geared towards client-server applications talking over sockets. The idea here is that you want to be able to register a server service so that clients can find it. When we say register, it's essentially advertising, and you want clients to be able to do name resolution so they can find the server. And they do this in a network or namespace independent manner and a transport independent manner. And as I've said, it's very much tied to sockets. The advantage of using sockets here is that it's a very low-level protocol, and there's no protocol. So it's a very low-level protocol. There's no additional protocol on the wire, so you have a lot of flexibility. Okay, so here's some of the concepts that we've introduced in R&R. Rather than talking about networks, now talk about namespaces. In the past, you've got like Microsoft networking, or you talk about a network networking, whereas in reality, you might find that a particular network vendor might actually have more than one namespace. You can, for example, you can see SAP and DS over there. They're actually somewhat very different namespaces, and the directory service namespace being hierarchical versus one could be very flat. Well, it's very flat. And so we basically say that we're going to talk in terms of namespaces rather than just networks. Services are identified by GUIDs or GUIDs. GUIDs are globally unique identifiers, and there are a 16-byte value, so they're pretty big, and you can generate them using a program called uuidgen.exe. And when you run this program, it takes time of day and your net card number and some other stuff and generates a number which is pretty much guaranteed to be unique. So you can generate this number once and just use this as the identifier for a particular service. And the final concept that we've introduced here is basically the set of addressing structures which are very flexible in the sense that you can use internet addressing or IPX, SPX, and a whole bunch of other things. The details actually are in the SDK, I believe. If you look at the NSP API.h header file, it will show you all the structures involved. Okay, again, I've just listed a subset of the APIs, the more interesting ones. Enum protocol basically enumerates protocols you have installed on your local machine. And protocols are essentially transports in this sense. So you can query things like, okay, what protocols do I have? And of the ones I have, do they support, are they reliable? Do they support connection-oriented stuff and so on? Then we have the get address name API. This is the name resolution API. So you specify a service type, the GUID. You specify a name of the instance of a service you want to connect to, call this API, and it will actually go ahead and try to resolve it using whatever mechanisms that's available to it. The get service and the set service APIs are the server-side APIs in a sense, and that is the way you would go ahead and register your service or advertise it. And currently we do not support browsing for arbitrary services across namespaces, but something we would like to do in the future. Okay. Writing an R&R provider, well, again, DLL based. That's just a entry point you can call, which is the np load namespaces, and that goes ahead and sets up all the appropriate tables of a table of pointers to functions and so on and so forth. R&R itself is implemented as a DLL. In fact, it actually lives in the WSOC32.dll right now. And like MPR, it just passes its calls down to the various providers until the appropriate one accepts it or rejects it. Okay, now we're going to get onto some user interface related extensions to the system. First of all, there's the WinFile extensions. Again, WinFile is the file manager, for those of you who are not familiar with the executable name. And it says in the slide that you can extend WinFile to handle network-specific operations. That's actually not true. You can extend WinFile period, so you can use it for non-network file systems as well. And basically what you do is you have an extension DLL and you specify this extension DLL in the registry so that file manager knows about it. And WinFile, when it starts up, will read the registry and load your DLL, and then it will call call a known entry point to negotiate, like what menus do you want to bring up, any menu items you have, etc., etc. And what this will achieve for you is that in the file manager, when you look at the menus, you add a new menu. So you can say, I've got the X file system menu over here, and then you can select a file and go to this menu and perform an action, and then the appropriate course will be routed to your DLL and tell you, look, hey, this, the user just click this thing, and then your DLL can actually find out what the current focus is in terms of what files the user has selected, what directories, etc. You can perform your own network-specific operation on that section, or file system-specific operation. Okay, got a question?
The print manager have the same type of
Okay, the question is, does print manager have the same type of extensions currently? No. Okay. Permissions at dialog extensions. This is very much like the file manager extensions. It's just a little bit more convenient because different people, different networks might want to do their own permissions, and you don't want to actually open up the file manager and see permissions, permissions menus. So what we've let you do here is basically just hook the permissions dialog. And this is part of the NPR spec. It's actually documented in the NPR spec, so at least in the latest ones. And you can just extend NPR that way. So provider, when someone goes to the file manager, selects the file and hit permissions and say set rights or permissions, and that particular file belongs to your network or your file system, you get a chance to bring up your own DAOs to do your own editing of permissions or audits or whatever. Question?
This is actually regarding the previous slide, the blue file. We have a file system that isn't, sort of the standard Unix directory setup kind of thing. And is there anything in the blue file extensions that would allow us to sort of display the file system differently? I mean, you get what I mean?
Okay.
Display different format than just directory / or backslash.
Right. So the question is, you've got a file system which is not Unix-like in the sense of how it supports directories and so on and so forth, and do the file manager extensions allow you to change the format that file manager use to display the file system? And answer, I'm afraid, is no. We cannot change the main panes that display the directory structure and all those things. All you can do is select something and actually perform an operation on it. We do not change the main display windows. Okay, some cautions. Be careful when you specify a network provider or order. Most people are very tempted to put their network at the top of the list, but of course, if you happen to be a very slow network or can be a very slow network, then every user basically has to pay the penalty for everything. A couple of hints are, for example, you might want to reject calls as least you can for the routing cases. I mean, if someone gives you a syntax, a remote path that's obviously not yours, don't even bother doing anything else, just return, not mine immediately. Same is true if someone gives you a username that's not yours, a username syntax or anything really, that as soon as you can detect that it's not interesting to you, throw it out. Also, don't leave UI implementation until last. Most people will, in fact, write redirector first and do all the pieces on top of that later. But you really need to think about how your network provider or your file system is going to interact with the rest of the system. Because quite often you might find that you want the file manager to do something different as a result of you returning a specific error code. Or in a specific case, you might want to push up a different dialog or do something different. Those are things we at Microsoft can probably accommodate very easily, but only tell us about it early enough and not a week before we ship final product. So think about these things early on, even if you do implement them fairly late in the game. Okay, summaries. There are various variety of mechanisms available for integration of your network into the system, or designed to make it seamless. And it's still evolving. We're still making improvements as we go along, and more capabilities will be added. So if you got suggestions or requests, feel free to come and talk to us. And Dave Beaver, of course, is the main point of contact. And that's pretty much it. Okay. Before I take questions, I actually have a couple of people who are true experts in some of the areas I've just talked about. So do those guys want to come up here, Manny and Krishna? So right here. And Dave can join us as well if you want.
Yeah. As an expert in true random things.
Yes. Okay, questions?
See any visions for that? Just put it up.
Apple Talk name support, right. If someone wants to write a provider for that, there's no reason why you cannot. I mean, there's nothing what I've said which says that you can't do it. But I've not done an example of it, correct. Sorry, can you hear a question? Does Microsoft provide that? Well, we do have the services for Macintosh server that Macintosh clients can talk to, but currently I do not know of any plans to do the opposite direction. No plans, Dave says. Right? Any other questions?
I have a question back here.
Okay.
With regard to the getting password in a clear, the provider, and having to then deal with it, are there any services for plans for some kind of an encrypted authentication service? Assuming I want to write both provider and a server and make use of the login services at both ends, so I want to leverage off of everything you've done. Is there any way I can only receive an encrypted password and only send that over the net?
Okay, so what you want to do is you want to have a server and a client, and you want to send an encrypted password across the wire, right?
Yeah, assuming I don't want to have responsibility for encryption. I don't want to have to worry about whether I'm the right one.
Right.
And you're pursuing, what is it, C2 certification?
Right. Well, we actually don't have any function that you can direct call to do encryption, but there are lots of published algorithms which give you a one-way encrypted function, and that you can use any of those domain. Well, I don't know if they're public domain, but there's certainly some well-known algorithms that you can use to do one-way encryption, and we do not supply that.
But if I wanted to re-log in on the server end, that one-way encryption isn't going to work. What I need to do is, assuming I want to kick off a batch job at some later time or just impersonate. To impersonate, I'll need the password in the clear to re-log on or to...
Well, if you want to re-log on the server side, you either need to have a two-way encrypted so you can unencrypt it, or you need to basically have a way of logging onto NT system on the remote side, just the one-way encrypted one. And that support, well, I don't really have any information on that right now, but we should come and talk to Dave Beaver, I think, and myself, maybe after this, to take it offline. That is actually quite a deep topic.
Thank you.
I have a couple of questions about the map. First question is, you said that the map, when the map sees a portion of path name or a path name, it presents it to all the registered providers until one of them accepts it, or is it is this done sequentially or is it done in parallel? And what happens if more than one provider accepts a portion of a path name?
Okay, basically the rule, the MUP's going to send you the entire path.
Yes.
Multiple providers can accept path, and then we have this is why we have the priority ordering. If there's multiple providers that accept the path, the MUP is still going to wait for all the responses, and it will take the one of highest priority.
Okay, how are the priorities set up at registration or registry time, and
they're just set up in the registry. There's a key for providers called order,
right,
and it just lists them in sequence of priority.
Okay. The other question was, does the map hold references to any file system objects, and is there any way for a file system to invalidate to issue invalidations on objects that are cached by the map. Suppose you're holding, you're caching in the map a portion of a path name that belongs to my file system, and the file system does something that makes a portion of the path name go away. How can I notify the map of that event because the portion of the path name has become invalid?
Okay, the answer to that is you can't. What we've done to make that possible is that the cache has a short timeout. It's probably, I can't remember what it is. It's on the order of 10 to 15 minutes. So when that time passes, the cache will be invalidated, and then when the request comes back through the map, we'll report it to all the file systems again, and then you'll have a chance to reject it.
Okay. Now, the first part of the question was, does the map hold any references to file system objects?
Okay. The answer to that question is yes. The MUP will actually open a handle to your file system when you register with a MUP, and won't close that handle until you deregister.
A single handle for the entire file system, or is it per directory?
A single handle, right. It won't hold handles except for files that are mail slots. That's the one exception. But for normal files, the only thing the MUP does is it looks at the string, it'll go through this matching algorithm. If it finds something, it'll throw it in the cache, keep a reference. It won't hold a reference for that file. The only thing the MUP does from then on, as long as the reference is in the cache, is it will remap the file name and return status reparse to the file system, so your file system will get it. There is reference
and if the file has disappeared, I can then reject the request.
You're free to reject it,
okay.
Yeah.
All right.
You talked about providing extensions to the Win file, and the question, I believe the documentation for that should be in the SDK or the DDK. Is that correct?
If it's not in SDK or DDK, we'll make sure that it's made available. Dave's listening.
Okay.
Is it SDK?
With the Win file extension.
Is that in SDK then?
Yeah, yes it is.
All right,
Yes.
someone says yes, they've seen it.
All right, good.
It's a bit buried, but
if we take enough pains to look for it, we should find it.
Correct. And if you can't find what you need to know, or if it's not clear enough, come and talk to us.
All right. Now, the next question is that I believe there's a limited set of messages which can flow back and forth between the Win file and the extension DLL. Now, that list of messages, is there any change in that to whatever was there in NT 3.1, or is it the same?
No, it's essentially the same. Those messages just let you query what
Right.
files are selected and what directories, etc.
Okay.
We have not extended that. Although, if you do think of more cases of things you want to do, you can just let us know, and we'll try our best to accommodate it.
Do you use OLE for any of this integration?
The question is, do we use OLE for any of this integration? Currently, no. Sorry.
next to the microphone.
Okay. Just wondering what everything you've described here is in common with Windows 95.
Do you get that? I didn't get
What is common to Windows 95?
Oh, okay. So the question is, what is common to Windows 95?
Yeah, the assumption is that everything here would be.
All the WNet functions that are supported by Windows NT Daytona are also supported by Windows 95.
Right. What about below the Win32 level?
Below the Win32 level, specifically the NT providers and those things. They should be very similar because the Win95 interface was based off the NT one. So I think if you already have an NT one, it is extremely similar. Windows 95 might have two additional entry points that can be made use of. Okay.
The problem with that is that the service provider API is the same. However, the code underneath it may wind up needing to be wildly different.
Right. So where your provider talks to your redirect will be very different, probably.
The fact that the API is the same does not necessarily indicate that you can use the same code on both systems. However, there's lots of similarities, so a lot of code may port.
Questions?
Any more questions?
Okay.
Okay.
Are there any restrictions as far as what you can do on a Win file extension, like put up other windows or use a PDI function?
Okay, so the question is, are there any restrictions on what you can do to the Win file extensions? And pretty much no. I mean, you've got a handle, and you can pop up your own dialogues, and you can do anything you want.
Can you accelerators and other things? And how do you arbitrate the same function keys with multiple extensions?
Okay, so the question, can you use accelerate and how do you arbitrate function keys between the various functions? I'm not too sure on that one. Well, the menu items will certainly work, and I think if your mnemonics are unique, there certainly should be no problem, or there's no way we can guarantee that you can that two menus could use the same mnemonics, and it's going to be very hard for us to arbitrate that.
I'm thinking of multiple ISVs implementing WinFile extensions in the same person's machine.
Mm-hmm. Okay, yeah, if you have multiple ISVs implementing the same extensions, then you will have multiple menus, and each of those menu items, as they are clicked, will go to the correct extension DLL. But the accelerators and mnemonics, that's a slightly more difficult problem, and and I'm not too sure whether we actually arbitrate that one or not right now, to be honest. I can give you if you come to me after this and give me your email address or something. Next question.
In the supplemental credential, you talked about some of the deficiency in the service, and that if you wanted to do something like a WNet ad or something, ad connection, you would need to become a user. Can that be done without a password? Is there a mechanism for that?
Okay, I'm not sure I understand your question. You're saying that for the supplemental credentials, like you can supply a separate username and password where you don't have to. Okay, in context of a service typically runs as its own process and is logged on as a local system. So if your service tries to access the network logged on as local system, chances are you will not have the appropriate access to the remote file system. So at that point, if your service needs to access something, you will go ahead and actually specify the supplemental credentials. So you can probably create an account on the remote server for this guy, and when you actually do this, you specify that account and that password. Okay, the question then becomes, doesn't that imply that you've got to save the credentials somewhere for the service? The answer is yes. When you configure a service to log in as a specific account, you also have to specify the password that the service logs in, and that gets stored away in the system in a secret place, encrypted. Yes, not telling you.
We have to kill.
Access fits in with the NetWare API model, which is this drive access.
Well, the question is how does the UNC access model fit in the NetWare model, which uses drive letters? It just supplements it as far as I can say. As far as I can see, your drive letters will still work if you have a mapping of X colon to a particular path. You can use that. If you want to go ahead and access server directly using a UNC name, you can do that as well. So it's kind of like supplemental rather than conflicting.
They're not mutually exclusive. Right. The question is, the original question really wasn't about drive letters as much as it was about the NetWare APIs, which actually, some drive letters are down there. Do you know?
Right. It does work because, well, I don't know what any complications with that.
Hushed conversation. There are people from Bell in the audience that might want to add something. I don't know if they're really interested.
Well, we do know it does work because the network, the client services for NetWare that should run with Windows NT, you actually access something using a UNC name. And what we do is we actually do open a file. I'm not sure what exactly you're referring to in terms of requiring a drive letter, because you can certainly access something without a drive letter.
network client's APIs to access clients. One of the things that you have to do with the API is something that in effect is a drive method or refers to a mapped drive method, which provides the basis from which the file name is interpreted. It's a bit like the route that you talked about elsewhere in this conference, the separation of routes from file name, things done relative to some provided route.
The question is more, does the network directory support UNC?
Yeah, well, the question is in fact very much with regard to how would you implement UNC on a network redirector. And why don't you come and talk to us offline after this? We'll see if we can try and understand the exact question better.
Yeah. The basic answer to that is that in fact both our network compatible redirector and the Novell redirector do implement UNCs, and they do, there is a network API. Brady, did you have something to say?
It's the object manager that does that first. And you've got to, above that, we have tools to take the X, and we're the guys that map it up above. When it goes into the object manager, he's the guy that has that symbolic link to translate it back to the full name when it gets cleaned up.
Yeah, Brady's answer, if I can paraphrase it, is that it's the APIs. The redirector underneath doesn't really know anything about drive letters. He just gets a /device / blah 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 blah. Joe Lynn will talk more about that during his talk. So the mapping of those things is the responsibility of the object manager, who does that for you, and getting that linkage into the object manager is actually the responsibility of the redirector or the mapping. If I know in Novell case they actually have a map that you can run that does maps drive letters to network shares. We've integrated ours into NetUse. Both of them do effectively the same thing. They simply map a drive letter onto a device down underneath inside the redirector. And then it's the redirector's responsibility to translate that. So the APIs have to do that same. The APIs talk ultimately to the redirector, so that same sort of mapping will occur there.
Use in the network API is not reflected in the underlying protocols. Right. Okay.
Any question behind there? Go ahead.
The symptom coming from, but right now there's no ability to supply different credentials for the same endpoint, or actually no. I mean, at least in 3.1, I haven't gotten deep into 3.5.
Okay, so the question is regarding the inability to specify multiple credentials for the same endpoint, right? So
well, it's certainly not the same endpoint in the network sense, but the same node.
Okay, so the same node, right? That's very much depends on your particular network. With the Microsoft network and the LAN manager network, it is a restriction of our redirect that you can only talk to a particular server in one particular context for the same machine. And for NetWare, well, maybe some of the people from Novell can answer that question.
That the same thing happens with the Novell redirector.
Right.
Yeah.
So,
okay.
No. So the question is it a fault of the APIs, or is it something that's underneath it? This is pretty much what happens at the redirector level. If you implement a network that allow multiple credentials across the same connection to us from one computer to another, then it will just work. So it's not a restriction at the API level.
What is the intended use of the RNR interface, and how does it interact or relate to UNC names?
Okay, well, the question is how do you use the RNR interface, and how does it interact with UNC names? I'll answer the second question first, and basically there's no interaction between that and UNC names. UNC names are primarily for IO operations, and RNR is very much a much lower protocol. We're talking about sockets. So if you have some arbitrary service out there that already has a a well-known socket number that you send packets to and that kind of things, and it wishes to advertise itself, or clients need to find it, that's where you would use R&R. You would use R&R APIs in conjunction with Windows sockets to actually do that kind of functionality. It's completely independent from UNC names.
Some place where I could find some more information on a restriction as far as the Unicode naming scheme is concerned, and does the MPR do any kind of parsing as far as that name is concerned? Does it have any restrictions on the characters in it and the length? And I do know that there are certain applications that seem to break with certain length, a length greater than, for example, 10 or 11 characters.
Okay, so there are two questions here. First of all, you know about the syntax of the Universal Naming Convention. Yes, it's very simple. It's double backslash and then followed by component backslash component, and the limit, I believe, is 255 length. UNC names, systems. Yeah. You have 255. So that's the only.
Well, there's actually an API. There's actually a way to express that so you can have no from the Win32 end, so there's no limit to the length of it. Or some very large limit beyond 256.
Is that a question or a comment? Or? Okay, you say there is a way to suppress that so you can have unlimited size to the UNC?
I don't know if it's unlimited, but...
Twice the size.
It's a convention where the 256 character limit doesn't apply. I don't remember whether
okay. I don't know anything about that, but okay.
Don't know anything about that either. So, okay,
So is that broken up in any form? In the sense, can the server name be... well, there are two questions, two parts to this. Can the server name be arbitrary as long as the length is less than 255? Or the server name and the share name have to sum up to 255 characters or less? And is there any restriction on the characters that are there in either server name and or the share name?
Right. Okay. There are no arbitrary restrictions on how long the server name has to be, as long as you follow the usual rules that your server name cannot have a backslash or some. There are a bunch of characters that we're restricted to, that we don't let you use, but in general, each component can be as long as it needs, as long as the total is less than the limit. The characters that we don't allow, do you remember what they are? Semicolon? No, right. It's probably in the SDK. If you can't find, I remember off the top of my head. And the second part of your question, let me just finish that, was as far as MPR is concerned, does MPR do any parsing of names? Does it have any restrictions? MPR, again, does not understand names. It just gives the remote names that it gets to various providers. So it does zero parsing of names.
Joe's going to talk a little bit more about this, I think, in his talk this afternoon. So you might watch what Joe's going to talk about. It might make it a little less confusing or more confusing, depending on how that turns out.
One final thing. Do you intend to provide any sort of mechanism for different file systems to integrate as far as the file manager is concerned in the security option? You've got a little security option in the file manager. I know that you'll allow us to modify the permissions, for example, put up a different dialog box. But what about allowing other file systems to add their own ACLs and stuff like that through one common mechanism?
Currently we don't have that, but that's certainly something that is desirable, and we're looking to that for the future. Currently, no.
Okay, why don't we peel out now and did you have a question?
I want to know what the server name can pull Unicode.
Can the server name be a full Unicode name? Can you use all the Unicode characters? There are some restrictions. Space is allowed, probably double quote isn't, I would bet, because you have some way of embedding a space. And backslash isn't allowed, but it's out there somewhere. But other than that, yeah, Unicode's allowed. The server name, what the server name is, I mean, this is actually, there's two questions going on here. The first one is, what's namespace your server is in? And the second one is, what's Windows NT going to allow you to specify as a server name? So Windows NT is going to allow you to specify pretty much anything as a server name. Inside the UNC rules are that you can specify just darn near anything, and you can't have probably double quotes and a backslash in it. If your namespace on the wire for the name lookup for the server supports, and the characters it supports are another question entirely. So, and we don't have any control over that, so we just, here's the UNC naming convention. If you can support all of this, that's fine. If you're somebody like Banyan, you have to put % signs in your names and all that. That all works fine. Up to you. It's a question of what your namespace holds. All right. Why don't we go ahead and have lunch?